Good day everyone, I am Jan Albert T. Vergado and I'll be introducing the topic Torricelli's Theorem, focusing on the background and key concept. What happens when water flows out of a tank? Let's start with a simple question. Kapag may tangke ng tubig na may butas sa gilid, gaano kabilis lalabas ang tubig? At paano natin ito makukompute o makakalkula kahit wala tayong measuring tools? Dito pumapasok ang Torricelli's formula or theorem. Isang paraan para ma-predict natin ang bilis ng paglabas ng tubig gamit ang physics. Evangelista Torricelli, Italian physicist and mathematician, student of Galileo, discovered the speed of efflux formula. Ang theorem na ito ay pinangalan kay Evangelista Torricelli, isang Italian physicist at mathematician. Siya ay naging student ni Galileo at kilala sa pagdiskubre ng formula para sa bilis ng pag-agos ng tubig mula sa isang butas. What is Torricelli's theorem? Describe the speed of fluids flowing out of an orifice. Act like the water is falling from a height, used to estimate exit velocity of fluid from a hole. Ang Torricelli's theorem ay nagsasabi na ang fluid na lumalabas sa butas ng tangke ay parang nahuhulog mula sa taas ng fluid sa ibabaw ng butas. Ibig sabihin, mas mataas ang tubig sa tangke, mas mabilis itong lalabas. Ginagamit ang theorem na ito sa pag-estimate natin ng mga exit velocity ng fluid. Torricelli's formula. V is equivalent to square root of 2gh, which is yung V ay speed of water coming out. Ito yung bilis ng tubig palabas. Yung G ay acceleration due to gravity. At yung height o yung H ay height ng vertical ng tubig mula sa surface hanggang sa butas. Key concepts. The higher the fluid level, the faster the exit speed. Based on conservation of energy kinetic and potential, assume ideal conditions. No viscosity, no air resistance, no steady incompressible flow, atmospheric pressure at the outlet. Para gumana daw ang formula ng tama, may ilang assumptions. Wala dapat friction o viscosity, steady at incompressible ang fluid, atmospheric pressure lang sa labas, at maliit lang ang butas. Importante din na matandaan natin na mas mataas ang fluid level, mas mabilis ang flow. Where is Torricelli's theorem? Ito yung mga applications. Marami itong gamit sa real life. Ito yung mga tulad ng water tanks and reservoirs, dams releasing water, which is yung example photo ko dyan sa baba, sa right side. Then, engineering drainage system, fountain design and fluid nozzle. Kaya mahalaga na maintindihan natin ang bawat ang konseptong ito sa engineering. Yan lang yung basic introduction at key concept ng Torricelli's theorem. Sa susunod naman na part ay ipagpapatuloy ni Francis Kalimlim para sa derivation at formula. Maraming salamat po.
Hello everyone, I'm Francis Zarina Kalimlim and I'm going to tackle how Torricelli's equation is derived. So, consider an open cylinder containing liquid up to the height. Let H1 be the surface of the liquid from the base of the cylinder. this is H1. And let there be a hole at a distance h2 from the base of the container. Let the depth of the hole from the surface of the liquid of the container be h. Clearly, we have h1 minus h2 is equals to h. Now, let's take 2 points from the container. One is at the surface of the liquid and one is at the hole. This is number 2. And applying Bernoulli's equation or Bernoulli's theorem, we have 1/2 density h velocity 1 squared plus pgh1 is equals to p2 plus 1/2 density v2 squared plus pgh1, 2, where v1 is the velocity of the liquid at the surface, v1, and the v2 is the velocity of the liquid coming out of the hole. But we all know that the cross-sectional at A1 is much bigger than the cross-sectional at the point 2, which is A2. Using the equation of continuity, which is A1 V1 is equals to A2 V2 V1 is equals to A2 over A1 multiplied by V2. We all know that A1 is much greater than A2. So we can equate this to 0. So V1 is 0. We can take V1 in the equation as 0. So let's take this and take V1 as 0. It will become 0. And V2, we can take it as V since V1 is eliminated. Taking all the terms to the left, we have P2 plus density GH1 minus PGH2 is equals to 1/2 density V squared. V1. Simplifying it, we have 1/2 density V squared is equals to P1 minus P2 plus density gravity H1 minus H2. But we all know that H1 minus H2 is equals to H. So we can replace it with H. Now we have P1 minus P2 plus density. Yeah. Simplifying it further, we have V squared is equals to density squaring the right side of the equation in order to get the value of V from the left. We have and distributing the 2 over density to the equation. Cancel. So this is the equation of velocity of the liquid coming out of the hole. But we all know that the surface of the container and the hole is open to atmosphere. It means that P1 is equals to PA, so as P2 is equals to PA. Replacing P1 and P2 by PA, we have PA minus PA over density plus 2GH. This will become 0 since PA minus PA is 0. So this will become 0, and what's left from the equation is P is equals to 2GH. And this is called the Torricelli's equation. Thank you everyone for listening.
Good day, I'm Janiela De Vera. I'll present an application of Torricelli's theorem using a tank with 2 holes at different heights. This problem will help us understand how height affects the exit velocity and the horizontal distance ng water kapag tumulo siya. Here's the given problem. A large open tank is filled with water to a height of 4 meters. 2 small holes are made on the side of the tank. Hole A is located 1 meter from the bottom. Hole B is located 2.5 meters from the bottom. Assume both holes have the same area of 1.5 square centimeters and the cross-sectional area of the tank is 1.2 square meters. Questions. Find the speed of the water. Here are the given values. Total height of water is 4 meters. Hole A is 1 meters from the bottom, so ang height above hole A is 3 meters. Hole B is 2.5 meters from the bottom, kaya ang height niya above hole B is 1.5 meters. Area of each hole is 1.5 square centimeters or 0.00015 square meters, and the tank area is 1.2 square meters, and our gravity is 9.81 meters per second squared. Sa part A, gamitin natin ulit ang Torricelli's theorem, which is V is equal to square root of 2GH. For hole A, substitute natin yung values niya. Ang makukuha nating sagot is 7.67 meters per second. For hole B, which is, ang height niya is 1.5, ang makukuha nating velocity is 5.42 meters per second. So, water from hole A exits faster than from hole B. Sa part B, tinatanong kung aling butas ang may mas malayong maaabot ng tubig horizontally. Masasagot natin to using projectile motion. Since pareho silang horizontal ang direction ng paglabas ng tubig, ang layo ng tatalsik ay nakadepende sa dalawang bagay. First, gaano kabilis lumabas yung tubig or exit speed from Torricelli's theorem, and gaano katagal siya nasa air or time of fall mula sa butas hanggang lupa. Yung time sa air ay galing sa T is equal to square root of 2y over g at yung range ay R is equal to Vt. So, kahit mas mabilis ang tubig sa mas mataas na butas, kung mas matagal bumagsak yung tubig sa mas mababang butas, baka mas malayo ang marating niya. So, ang calculation ng part B is i-substitute lang natin yung mga given values. Makukuha natin yung time sa A is 0.45 seconds. Para mukha yung range ng A, i-substitute natin yung velocity ng A at ipag-multiply natin ang time ng A, which is makukuha natin na range ay 3.45 meters. Same with B. Let's substitute the time. Ang makukuha nating time ng B is 0.71 seconds. Ang makukuha nating range kapag sinubstitute natin ang velocity ng B at ng time ng A ay 3.85 meters. Mas malayo pa rin ang range ni hole B kahit mas mabagal ang speed dahil mas matagal siya naka-airtime. That's all. Thank you.
Hello everyone, I am Jamaica Luis and now let's solve another problem, which is a large tank open to the air is filled with water up to 5 meters high. A small hole is made in the side of the tank 2 meters above the ground. Ignoring friction and assuming the water level stays constant, at what speed does the water flow out of the hole? So makikita natin yung diagram dito sa ating example, and yung ating given naman is yung height of the water surface from the base is yung 5 meters. Ito, yung H dito. And yung ating height of the hole from the base naman yung 2 meters here. And to get the value of our height, dot H is i-minus lang natin yung 5 sa 2 meters, which is makukuha natin yung 3 meters here. So, sa ating equation na na-derive from Bernoulli's equation, which is Torricelli's na, isa-substitute lang natin yung mga given values. So, substitute natin yung 2, tas yung G naman natin is 9.81 meter per second square. And yung nakuha nating total H kanina na 3. So, our final answer is 7.6720 meter per second.
Hello, I am Marcos Rafael Birapsing, and I am here to present problem number 3 of our chosen topic, Torricelli's equation. So, problem number 3 states that a cylindrical tank open to the atmosphere is filled with water to a height of 9 meters. A small hole is located on the side of the tank, 3 meters above the base. What is the speed of the water as it exits the hole? So, i-drawing natin para mas madali siyang ma-visualize. Kunwari dito yung butas. Yung height ng butas mula dun sa ilalim ng tank is 3 meters. Yung height naman mula dun sa surface ng water hanggang dun sa ilalim ay 9 meters. So, ang formula natin sa Torricelli's equation, hindi naman siya nagbabago. V is equal to the square root of 2 GH, where yung V, siya yung velocity. G is yung gravity, which is 9.81 meters per second squared. Yung H naman is the height from the hole to the water surface. So, ang height natin dito sa problem na to ay ito siya. H is equals to 9 meters minus 3 meters is equal to 6 meters. Ngayon, pwede na natin siyang i-plug in dun sa equation. V is equal to the square root of 2GH. V is equal to the square root of 2 times 9.81 meters per second squared times 6 meters. V is equal to the square root of, lagay natin sa calculator, (117.72 meters squared over second squared). So, yung final velocity natin is 10.8499 meters per second, or just the speed of the water as it exits the hole is 10.85 meters per second. So once again, our topic has been Torricelli's equation. Thank you for watching and see you in the next video. Bye bye.